High pressure or high volume, which blower do you actually need? Here is the trap. The biggest airflow number in a catalog is normally measured near zero resistance, while the highest pressure occurs near zero flow. Those two headline numbers cannot happen at the same time. Imagine two replacements. Blower A moves a huge amount of air with its outlet open. Connect the real filter, coil, silencer, duct and diffuser, and its flow collapses. Blower B can generate much more pressure, but on a short, open air path it may bring unnecessary speed, power, noise or cost. Neither is universally better. The correct answer is the blower whose performance curve reaches your required airflow at your system pressure. First, separate the two quantities. Volume flow is how much air passes through the system per unit time. Pressure is the energy per unit volume available to overcome resistance. More filter media, longer duct, smaller passages, sharp fittings, coils, cyclones and nozzles all add resistance. In many turbulent air systems, resistance rises roughly with the square of airflow. Double the flow and the pressure requirement may approach 4 times the original value. Now place the fan curve and system curve on the same graph. The fan curve usually falls as flow increases. The system curve rises. Their intersection is the operating point. A high-volume candidate may have the farther right curve, while a high-pressure candidate may hold its curve higher. But the project does not buy the end of either axis. It buys one intersection, required flow at required pressure. Watch what happens when a clean filter becomes loaded. The system curve becomes steeper, so the operating point moves left, pressure rises and delivered flow falls. Opening a damper does the opposite. This is why a free air demonstration cannot prove performance inside an air handler or process line. For a large, open ventilation or drying path, the duty point may sit far right and relatively low. A volume-first shortlist can make sense. For dense filtration, a cyclone, a long duct network, a compact heat exchanger or a nozzle, the duty point moves higher. A pressure-first shortlist becomes more likely. A larger blower can sometimes deliver both high flow and high pressure, but motor power, speed, sound, size and cost also rise. There is no free corner of the curve. Geometry helps shape the curve, but it is not a substitute for data. Forward curved, backward inclined, backward curved and other wool designs can be configured across different sizes and speeds. Do not select only from a blade label. Ask for the tested curve of the complete blower, at the stated air density, speed, and configuration. Then mark the required point and a realistic operating range, not just one perfect dot. Also check the stability and efficiency region around that point. A curve intersection is necessary, but it is not the whole purchase decision. Confirm input power and motor margin, maximum speed, sound data, inlet and outlet conditions, temperature, contamination, materials, drive arrangement and control method. If the process varies, repeat the check at minimum, normal and maximum flow. If a variable speed drive will regulate pressure or airflow, map the control range instead of assuming the full speed curve applies everywhere. Here is the fastest way to write a useful request for quotation. State the required airflow together with the external static pressure. Add air temperature, altitude or density, the medium and contaminants, the resistance estimate or system curve, control method, allowable sound boundary, power supply, envelope and service access. If the pressure estimate is uncertain, list every resistance component and its condition, especially clean and loaded filters. So, high pressure versus high volume is the wrong final question. The better question is, which complete blower stays inside the acceptable operating region across every required duty point? Start with flow at pressure, and the right family usually becomes much easier to see. For a curve-based review, send Longwell your airflow, pressure, system layout, and operating range. The useful conversation starts at the duty point.